Today I'm going to show you how to use the marker function featured on some of the B&K Precision's arbitrary waveform generators for applications requiring signal synchronization. This function is available on B&K Precision's models 4075, 4076, 4078, and 4079. The marker function allows users to select a portion of the arbitrary waveform at any point and create a separate 5-volt TTL signal output. The signal level is high only during the time at which those portions of points are output. Here's an illustration of what this would look like. B&K's arbitrary waveform generators that support this function currently can select and produce this marker output up to 4,000 points long. Marker function is useful particularly in applications that call for selecting a specific time of a signal to initialize and trigger another signal, or for precise synchronization between two signals. Here's an example. I have a B&K Precision 4076 and a 4045 here. On the 4076, I have preloaded to the arbitrary waveform memory a signal with some added noise in between, which looks like the following. Suppose I want to output a clock signal to an external system exactly whenever this noise occurs. I will demonstrate to you how to output this clock signal from the 4045 by using the marker function of the 4076 to serve as an external gated trigger input to the 4045. The arbitrary waveform I created has 800 points in length. The noise created starts at the arbitrary memory address 445 with a length of 50 points. In the Art menu of the 4076, I will select Mark, then select ADDR for address, and set it to 445, which is the beginning point of the noise. Then select Length and set it to 50, for this is how long the noise is in the arbitrary waveform. Now I will select On, and the rear panel BNC connector labeled Marker Output will have a 5-volt TTL level output in sync with the selected chunk of points where the noise occurs. We can verify this by triggering the arbitrary waveform on an oscilloscope. Here I am using a B&K Precision 2530B DSO, triggering off channel 1, which is my arbitrary waveform, with channel 2 showing the 5-volt marker output from the rear panel of 4076. Notice the positive 5-volt level being output precisely between the points where the noise occurs in the arbitrary signal. Now I will connect the marker output to the trigger in BNC of the 4045. On the 4045, I will select square function because I want a clock signal, and I will set it to 100 kHz frequency for demonstration. Amplitude is kept at 5 volts. Now press Mode and select Gate. Gated triggering is selected because in this example, we want a continuous clock signal to output during the entire portion of time where the noise occurs. Select EXT for external from the menu so that the generator will use the triggered input from the rear panel to trigger the main output clock signal that we have just set up. The complete setup should look like the following block diagram. With both the 4076 and 4045 main output turned on, I will connect 4076 to channel 1 and 4045 to channel 2 of the oscilloscope. The results should look like the following. This clock signal can be used to trigger, drive, or activate an external system designed to detect our simulated noise signal.